Welcome students to Chapter 2 of Abnormal Psychology. In this chapter we're going to be talking about research and how we do that in the field of abnormal behavior. So what is research? It is the systematic search for facts through the use of careful observations and investigations. And we know that if we mess up and we have inaccuracies in the field, that we can cause great suffering. So we try to go to great lengths to design our research appropriately and use solid procedures. The people who do this are called clinical researchers. They tend to discover universal laws and principles of human behavior. They search for what's called nomothetic understanding, or what's normative or common across a culture or group. They don't typically, on the other hand, assess, diagnose, or treat individual clients. And they do use the scientific method. Clinical researchers primarily depend on three methods of investigation: the case study, the correlational method, and the experimental method. And we'll talk about each one of those in turn. Case studies is the first type of research that we use. And that's where you have an individual or just a few individuals that we study at close range very carefully. It provides a detailed interpretative description of a person's life and psychological problems. It's the source of new ideas about behavior and discoveries many times because we're really focusing in on someone's behavior and we might find out something new. There can be tentative support for a theory, or conversely, challenge to an existing theory that comes from a case study. Sometimes there's also introduction of new therapeutic techniques or opportunities to study unusual types of problems in a case study. The limitations, though, have to do with bias, which we all have bias that we bring to everything in life. So there is low what's called internal validity or subjective evidence when we are, having a small group of people that we are viewing through our own unique lens. So we can't generalize our findings and say, on the basis of just these few people, there's a whole lot of support for what everybody might do. So the findings are limited in terms of their external validity or generalizability. The correlational method is the next type of method, and it's similar to the experimental method in terms of general characteristics that are used. There are typically many observations across a number of individuals. Researchers apply procedures uniformly. The studies can be replicated or copied based on the types of procedures that were put in place by the researcher. And then researchers use statistical tests to analyze the results. So when we're looking at a correlation, that's the degree to which events or characteristics vary with each other. So they're either going to tie together nicely or they're going to diverge. And the correlational method is a research procedure that's used to determine how much events or characteristics do vary along with each other. And the subjects or participants are people that are chosen for the study that are collectively called a sample. The sample should represent the larger population. So if you're trying to mirror the, what's going on in our country, you would want to have the same type of demographics in your study as we have in our country. These graphs describe positive and negative correlations. On the left-hand side, you see a very strong positive correlation between recent stressors and feelings of depression. And so you see the slope going up because those two things are very closely tied together. On the other side, the right-hand side, you see a negative correlation between the number of activities the person does and feelings of depression, because when people are depressed, they don't do a lot. So that's a very strong negative correlation. Correlational data is almost always graphed like this, and a line of best fit is drawn, as you saw. For that positive correlation, again, the slope is upward. The variables change in the same direction. Negative correlation, they change in the opposite direction or have a downward slope. And if the variables are not related at all, you will see no slope or no consistent relationship. You can see the magnitude or strength of a correlation is very important. When you have high or strong magnitude, variables vary closely together and they fall close to the line of best fit. And so you can see on the right-hand side a similar, very strong positive correlation with the variables all sort of clustered around that line. On the left-hand side, there's a weaker magnitude where variables do not vary as closely together. They're loosely scattered around the line. So there's really not a whole lot of good conclusions that you can draw about things hanging together or not. The direction and magnitude of a correlation are often calculated numerically, and we use the correlation coefficient, or the letter R, to describe this phenomenon. Correlations can vary from a perfect positive correlation of +1 to a perfect negative correlation of -1. The number indicates the magnitude, and if you have a zero correlation, there is no consistent relationship. Correlations can be trusted based on statistical analysis of probability. We look at statistical significance to determine if the finding is unlikely to have occurred by chance. If we see that less than a 5% probability exists that findings are due to chance, or p is less than 0.05, that's considered statistically significant. Generally, our confidence in our study findings increases with the size of the sample and the magnitude of the correlation. So all of those things are looked at in terms of, the conclusions that we can draw and how confident we feel about them. The third type of research is the experimental research, and this is where a variable is manipulated and the manipulation's effect on another variable is observed. The manipulated variable is called the independent variable, and the variable being observed is called the dependent variable. And we know that that's not all we necessarily will see when we do a research experiment. Sometimes we have confounds, which are variables other than the independent variable that may be also affecting the dependent variable. So we have three features to try to guard against those: the control group, the random assignment, and the masked or blind design, and I'll talk about those. The control group is where the research participants are not exposed to the independent variable, but their experience is similar to that of an experimental group. So they're involved in the same, usually, duration of the research. They have some kind of similar experience, but they're not getting that very specific treatment that the experimental group receives. The rules of statistical significance are applied to this group, and clinicians may also evaluate clinical significance in the group. We also have random assignment, where it's any selection procedure that ensures that every participant in the experiment is as likely to be placed in one group as another. So typically we'll generate a list of random numbers from a computer, and then we assign research participants to groups based on those random numbers. So there's no bias in who gets the treatment and who gets the control experience. We also have things called masked or blind designs, and that's an experiment in which the participants don't know which assigned group they're in. They don't know if they're getting the treatment or if they're in the control group. An example of that is the placebo therapy that is given to many research participants in drug studies. So the experimental group will receive the drug that's being studied, and the control group will receive a placebo or maybe like a sugar pill or something. And so they don't know that they're not getting a drug, but they are studied for what effect the placebo has on them, and it does have some effect. Then we have finally the double mask design, in which both participants and experimenters are unaware of the groups to which the participants are assigned. So that means that the experimenters that are working with both groups have no knowledge of who's receiving the treatment and who's not, so there can't be any bias that's introduced into how they're interacting with either group. Because it's difficult to do psychological research, clinical researchers often must settle for designs that are less than ideal, and they include quasi-experimental designs, not quite experimental designs, which are really the gold standard of what we would like to do every time. This list here, which will be discussed more in your textbook, are some of the quasi-experimental designs that we can do in psychology. Match designs, natural experiments, analogs, single subject experiments, longitudinal studies, and epidemiological studies. Last but not least, I want to talk about protecting human participants. Our researchers' primary obligation in any study that we do is to avoid physical or psychological harm for human participants. And so there are, at every organization that does research, an institutional review board, which is an ethics committee that is empowered to protect the rights and safety of human research participants. They review all of the studies that are being proposed and make sure that they're appropriate and that harm is minimized or eliminated to participants. These IRBs try to ensure that the following rights are granted to the participants: that they enlist in the study voluntarily; before enlisting, that they are adequately informed about what the study entails, or they have informed consent; and that they know that participants can end their participation in the study at any time. And they also try to make sure that the benefits of the study outweigh its costs or risks, that the participants are protected from physical and psychological harm, as I said, and that participants have access to information about the study. And finally, that their privacy is protected by principles such as confidentiality or anonymity. So we're not giving any, information out to the public about what has happened with them in the study. So that concludes Chapter 3, or Chapter 2. I'll pick it up with Chapter 3.